King, faculty with Neumont University, speaking with, let's go around the room.
Talon Lucinol.
Bastian Oxer.
Carl Thompson.
Dale Chetney.
And over here we have financial aid expert.
Nate Blanchard.
Awesome.
Oh, my hero.
All right, tell me about these robots. We built these robots in whose class?
Mr. Dr. Halladay, Professor Sir Guy.
Okay.
That one out, Professor Steve Halladay.
Very good. And what's the name of the class?
Principles of Software Engineering.
All right, before we talk about the class, make your robots dance and sing because it was a lot of fun watching them battle. Okay, so I came to the class, you guys put the robots down, you push a few buttons and they battle it out. So make your robot go.
Here's our robot Pancake.
And Pancake sings?
Yep.
Were all robots supposed to sing?
No, that was just flair we added.
Why is Pancake dancing?
Because it thought the hole there was the line, I assume.
Okay, turn it off. Tell me a little bit about the functionality of your robot.
So our robot uses all three of our motors mainly for forward pushing. We've torqued up all our motors using gears in order to have the most pushing power out of all the robots. And other than that, we just tried to add as much weight as possible to it in order so we could get the most traction and just shove other robots out of the arena.
So the idea is there's a circle, don't go outside the circle, push the other robots outside the circle.
And never stop moving for more than 10 seconds.
Oh, so once you've stopped, you're disqualified?
If you're flipped over or something for longer than 10 seconds, you're out.
Okay, so tell me about your design of your robot. Every robot has a different design. Tell me why you took the design that you have.
For our design, since we knew one of the major things that we were risking was being flipped, we wanted to get our robot as low to the ground as possible. So we made sure that these wheels were pretty much exactly level with the main brick. And other than that, we just made sure it drove forward and pushed things.
And then whose robot is this?
This is my robot Actions. So.
Okay, you two worked on this together?
Yes.
Yep.
Was it always pairs? Everybody was in pairs?
Actually, it was a group of three.
Groups of three. Okay, so you two were in this group. All right, so pull your robot back to yourselves
Alright.
and make it go. So tell me about your design.
So our robot was more of a.
Okay, great. Ah! All right, go ahead. Go ahead and turn it off. So your design is a lot different than Talon's design here. So tell me what your goal was with your design.
Our robot was more of a move around as much as possible, avoid the other robots, and then when you do take a robot and go for it, try and push it out of the ring. So we also have used touch sensors so that when a robot is in contact with a robot, it's going to go woof, just go faster.
I see. So if someone's in front of you, push really hard. Otherwise, get out of the way and let the robots fight amongst themselves.
We essentially took what is known as a pocket battleship strategy.
Uh-huh.
While waiting for our targets to try to demolish themselves, as soon as we find a target, come in contact, we're going to start shoving them out of the way.
I see. So that's how a good school fight would go, is if there's like 3 or 4 people that want to fight, you just let them battle it out, and then I'll take whoever's left over, and now they're exhausted. Is that the idea there? Very cool. So robots are cool. That's fun. Tell me the educational purpose of this exercise.
Well, what the robots construction and what they do as far as like battling or pushing cans out of a field or whatever is not nearly as important as what we're studying in this class, which is design approaches. We talk about neo-waterfall and agile development styles. And
So these are methodologies you're talking about. Okay.
Design project, design methodologies. And that's what the focus of the class is all about. Not so much on the robots, it's just how we go about building these robots as a project.
Okay.
The robot's just a fun tool that he uses to teach us different methodologies.
So there's several different types of methodologies. You mentioned waterfall. I presume there was some agile in there, scrummish,
Scrum
kind of things.
In fact, for this project, for the BattleBots, we're using Scrum.
Okay. So you did other projects, non-robotic related, using different methodologies?
Yes.
We did other projects
But it
with
wasn't-
the robots, but they were not dealing with BattleBots. It was either pushing a can out of the circle, or it was a slot machine.
So all projects use the robots, but you had to take different approaches to
Yes.
building your software. What methodologies have you used this quarter?
we've used Neo Waterfall, which is a slower approach. We start off by making a plan saying this is what the robot does and this is the subsets of what the robot needs to do in order to accomplish this one main task. And then we just go down and slowly get closer and closer to actually coding it. And then once we're ready and we know that we can code it up just simply and we know that's going to work, we start coding.
Okay. What other methodologies?
The other methodology that we've used currently is Scrum,
Uh-huh.
which we're using a modified version. We're only going like a week and a half.
Uh-huh.
And for that, it was essentially, how do you want to go about doing your battle bot? Our group got together, worked out a backlog, and then set up our sprint, and everybody was left to finish the tasks they wanted to.
Say, when we think about like how for an advantage of Agile over Neo Waterfall, it's pretty clear in the BattleBot system, in which case every match something different happens and you want to react to it differently. And say now how we've noticed by doing this battle the first time, we're going to do another battle later on Tuesday, and what we found from the first battle, we're going to have to use that to make our robots change and adapt. For example, making them more defensive, less prone to be rushing towards the edge of the field to push things out, make them have gear systems that can improve the torque of the wheels and such. And that kind of stuff we wouldn't be able to pull off if we're using Neo Waterfall, which is one build, one ship, one result. And as far as Neo Waterfall over Agile, what's made the Agile so easy is really honestly because the coding's basically already done for us because we've already done it in Neo Waterfall. And our code that we created in Neo Waterfall is likely much better than it would be if we were just doing Agile. Because when we did the Neo Waterfall, we had the design thought out clearly from the start, and when we went to code it, we were just translating our thoughts into code. And that led to a very reusable abstract code that was very easy to implement when we used Agile methods. And so that would be the advantage of the Neo Waterfall approach, is that your code is cleaner, more usable, and generally more efficient, I suppose.
Did that answer your question?
Yes.
That was cool. Good job, Dale.
Thanks.
All right. Well, the bots are cool, and it was fun to watch a battle. Everybody say bye.
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 I'm a Neumont. It's the best things
Don't
ever.
listen to him.
Say
Carl!